Welcome to All Things Simplified. This is a quick video using our knowledge of anatomy and pathophysiology, demonstrating location of heart sounds in the different valvular abnormalities. First, let's review the anatomy of the heart. Demonstrate using two-dimensional or three-dimensional model. Blood flows from right atrium through tricuspid valve to right ventricle, which then goes out to pulmonic valve to the lungs. Blood gets oxygenated from the lungs and goes to left atrium, through mitral valve to left ventricle, then pushed out through aortic valve to the body and back to right atrium. Our main focus today is aortic valve. Aortic stenosis is the inability of the valve to open due to a stiff valve, most likely due to calcification. To overcome a stenotic valve, we will see an increase in pressure buildup in the left ventricle, which requires the ventricle to work even harder to push blood through. This exertion of the ventricle over time causes the ventricular muscle to grow, get thick, also known as LVH, left ventricular hypertrophy, and decrease muscle compliance. In regard to where one will hear an aortic stenosis the loudest, let's think of someone bursting through a stiff door. They will have to exert more force. As they burst through the door, they don't just come to a full stop, right? They keep going. As we visualize the heart, the left ventricle aligns with the right atrium. So as the pressure builds up to force blood through a stenotic aortic valve, a high pressure flow against a stenotic valve will transmit sound in this linear position. We will hear the sound the loudest at the right upper sternal border, going towards the carotid. That stenotic valve also is responsible for a delayed carotid pulse, also known as pulsus parvus et tardus, and a paradoxical split, also known as reverse split. Usually we hear aortic valve open and closes before pulmonic, but because of disease state, we get reverse split, where pulmonic valve opens and closes before aortic valve.